Good day, sir. I'm Tun Yao, and I'm the team leader of Group A1 Humanoid. So before I start my presentations, I would like to introduce my team member first. So the first one is Chai Sunji, and the second one is Nok Kai Pin. The project is about projectiles, and we built a prototype for it. So to test out the prototype, we need a place, right? So let's move. So welcome back, sir. So welcome to my room, and this is the place where I do the experiment to test out the prototype. So sir, are you excited to see my prototype? Shall we? So yeah, this is the prototype that is used to collect the experimental data. Two tables are needed to build the platform. A red box is created on the wall for scaling purpose. To start the experiment, the prototype is first clamped to the table to stabilize it. The hardest part of the experimental procedure is to adjust the angle of capturing the projectile motion to be always perpendicular to the prototype in both horizontal and vertical direction. So this is the most exciting part. The spring is pulled until the bolt reaches the black line and it is released to shoot the ball out of the cannon. It is somehow oddly satisfying to watch the projectile motion in slow motion. So finally, the projectile curvature profile is created. So that's all from me, the part on how do we collect the experimental data from the prototype. Now I will pass my presentation to my lovely team members who will be discussing on how do we extract the data from the projectile motion video, the most important part in our project. Thank you, sir, for listening. Bye.
Exposure and examiners. I'm not cutting today. I would like to present to extract the data by using both theoretical and experimental method. So first of all is the XY displacement by using the theoretical formula. We use the string force Kx equal ma to find the a, and by using the dynamic formula, as we know the a, so we can find the v equal 5.70. So there is a two displacement, right? So because we use the front plane only, there is a x and y. So the dynamic formula also is given. So we can find the y and the x displacement. Important things is I would like to present one of the experimental method is called red box scaling method. Uh, we can see there is a red box on the wall on the experimental. So by using the PowerPoint, we know the height, and we draw a line to horizontal and draw a line vertical to the ball. So we can get the 1.23 inch for the height of the box. Uh, as we know, because the scaling, the real life, the red box, the height of the red box is 30 cm. So the 30 cm times 2.37x2 can get the f.88 ratio. So the x and y, since we know the inch, so we can get the times the ratio times the inch. The inch is one inch is represent 2.54 centimeter. So we can get the x and y value. Then uh, by use the x and y value, we can compare between the theoretical and experimental value. So you can see this percentage difference also consider high because of the drag force and maybe the human error. So next is finding the drag force. Finding drag force. So since we consider the theoretical don't have the air resistance, right, it's only the experimental. So the experimental, the vertical velocity, we use the vy equal the y minus the y naught over t. The horizontal velocity remain the same because no force acting on it. So the drag force formula, since we get the v, important is to determine the CD, the drag coefficient. The drag coefficient, we need to find the real numbers because the real numbers to determine the laminar or turbulent flow. So there's a real number formula. Uh, we can see the calculation of the Vy and the Vx. So the real numbers Since the row and the milk also the constant, so we put the velocity, the diameter also constant, so we get the real numbers of 4,614. So 4,614, it is over 4,000. Therefore, the drag coefficient is 0.2. 0.2. If it's less than the real number is less than 2,300, we use the drag coefficient is 0.5. So we can get the final, since we know the CD, all the values, we can find the drag force. So from the 20 points for the tables, we draw the curvature path by using the software Corel PhotoPen. So we choose the fixed 20 points of these all points. So estimator will know how come the 20 points in the table. So yeah, that's it.
Hello, good afternoon, sir. My name is Chai Shunji. I will be presenting about the FPS method for the experimental method. So, for finding the displacement using the FPM method is more or less the same as previously done by my teammate. It's just that this one is using the apps, the Corel apps, to draw the line in vertical and x direction, but the concept behind it is still the same. We just find the displacement in pixel and we convert it into displacement by multiplying the per pixel and get the displacement in in meter form. So overall, the concept is still the same like the previous one, and we can after that we can tabulate the data for the 20 point and compare the percentage difference between the theoretical and experimental method. So I will be not talking much about this. I will be explaining for the drag force part. The drag as for the drag force, the FPS method. From the original video for the projectile motion curve, we can find the total number of frames by using the VLC, and we obtain it to be 120, and we divided by the video length 6 seconds, and we get the 20 FPS for the whole video. So yeah, we can also take the reciprocal of it, and we get 0.05 second per frame. So after that, we wanna find the frame value. The frame value is found by taking the width of the ball. We calculate each pixel, and also we obtain the width of the two adjacent ball, which covered by this area. The adjacent ball in pixel, and then we take the value of this divided by the ball width, and we obtain the frame value to be 2.185. After obtaining this frame value, we multiply it by the second per frame, which is 0.05, and we obtain the time for the projectile motion is 0.109 second. So as we move on, after we obtain this, we can calculate the displacement in x and y direction. In x and y direction by actually using the same concept, just by multiplying the per pixel, and we analysis it to be in displacement in meter form, and then divided by the time to get the velocity. Just a simple projectile motion concept. So moving on, after that we will be discuss about the how to find the drag force. So we obtain the velocity is to be substitute into the drag force formula, but before that we need to determine the Reynolds number first. So after determine the Reynolds number by using the formula listed and substitute the velocity and the other constant value, we obtain that for each point, it is a laminar flow with the drag coefficient of 0.5. So substitute the value of the drag coefficient and also the velocity, we can obtain the drag force for each x and y direction, as shown in the report here, all this formula, and we can make the tabulation of data of it, and we can know which point have the highest and lowest drag force. That's the presentation for the FPS method. Thank you, sir.
By using the experimental velocity, so we can find the force by using SolidWorks software also safety. So if get the values from the SolidWorks, we can compare with the experimental force to find the percentage difference. Um, how to get the safety drag force value. So first of all, we can input the global go force in direction y, or if x direction we can input xr. So the equation go, we can input the equation, the formula. So the y direction is a GG force y. So this is a drag coefficient formula. For the initial condition, we can change in the general setting. The initial condition, we can, if the y direction, we can choose if the velocity is changed the 0.2, we can change the 0.3 and press OK. Press OK because my PC is lagging, so I don't press OK. So if we press the run, we can get the value like this, the GG force y. That's all my part. Thank you. I will pass to my teammate.
Okay, thank you, Kai Ping. So I will be talking about the conclusion and recommendation for our project. So in conclusion, our objective for our project has been achieved, and also we successfully built the benchtop apparatus projectile launcher. So from this, we can do the experimental analysis and also the theoretical analysis by focusing on two aspects, which is the displacement and also the drag force analysis. So from the result of this experiment, from the for the both red box scaling method and also the FPS method, the theoretical and experimental data for displacement measurement in x and y direction are having percentage different. This is due to some reasons such as for the theoretical formula, we didn't take account for the air resistance, while for the experimental itself, it will surely have air resistance acting on it. Besides for the FPS method also, there will be some human error when taking the small reading of the pixel in the CorelDRAW software, since it needs to be chosen the reference point very specific from thousands of pixels located in an image. And next, for the drag force analysis, the drag force in the horizontal direction will be always constant no matter the ball is in any position. On the other hand, for the drag force in y position, they will be differ because for each point, the gravitational acceleration force acting on it will be different. So for the three method, as mentioned previously, the red box scaling method, the FPS method, and also the CFD simulation method, these three methods have its own drag force analysis data, and the highest and for the highest and lowest drag force is recorded as shown here. So throughout the experimental data analysis, some error might occur when taking the reading of the displacement by using the PowerPoint or the Corel PhotoPen 2021. So in this case, the computer-based software such as SolidWorks for the CFD simulation has higher reliability and accuracy in obtaining the experimental data of drag force that we want. Besides that, lastly, we can also prepare an lab sheet for the future experiment using this type of projectile launcher prototype. So the recommendation for future work improvement of this project is that it can be improved to a STEM kit for as the projectile motion play important role in sport, weapon, and motion prediction. So due to the simple concept behind this project, the project itself is able to taken into dynamic lab on STPM or degree level. The result obtained can be also documented for further research. So besides that, this experiment need to be carried out in vacuum room or air resistant free area. This is because the high percentage difference is due to the air resistance or the drag. So for further researcher, they need to take this into consideration. Other than that, the prototype design component can be modified to consider less friction, and it will improve the result itself. Lastly, for the safety precaution, always wear glove when launching the ball because it will easily to get hurt if our hand itself pulling the spring didn't wear glove. It will be have high friction. Besides that, stable base should chosen for this benchtop prototype to prevent the prototype to easily damage the base when pulling the stick. So that's it for the whole video presentation, our group video presentation. Thank you, sir, for listening to our video.